In this video, we are going to explore the inverses of various functions. In the previous video, I never mentioned something that is really important about the inverse of a function. Well, the inverse of a function is obtained by reflecting our original function on the line y equals to x if and only if that original function is a one-to-one function. So we can find the inverse of a function if that function is a what? Is a one-to-one function. So we must firstly check if whether the given function is a one-to-one function before we can find the inverse of it. Remember that to check it if whether a function is a one-to-one function, we use the horizontal line test. So now I have few examples that I'm going to do just to show you how do we find the inverse of a function. So now we're going to start with the linear function. So now the first one is the linear function y equals to 3x minus 5. So now in order to find the inverse of this function, well, let me rewrite the equation. We have y equals to 3x minus 5. So now what you have to do is you have to swap your x and y. So now you're going to say x equals to 3y minus 5. So now you have swapped your x and y. So after swapping your x and y, then you have to solve for y. So now solving for y, you have to transpose this minus 5 to the left hand side, whereby you have x plus 5 equals to 3y. So now it will be minus 5 plus 5, which is 0. So now simplifying this further, you're going to say divide both sides by 3. Then you have y equals to x plus 5 over 3 as the inverse of this function y equals to 3x minus 5. So that's how you can find the inverse of a linear function. So now moving on to the second one, we have the exponential function y equals to half to the power of x. So now again we write our equation, half to the power of x. Then after you swap your x and y, so now this will become x equals to half to the power of y. So now you have to solve y, which is our exponent in our equation. So now if y is our exponent in our equation, then that's when now the logarithmic functions comes in. So now in order to solve this y, you will have to say y equals to log base half of what? Of x. In order to solve for what? For y as an exponent. So now it means y equals to log base half of x. It is the inverse of our function y equals to half to the power of x. So that's how you can find the inverse of an exponential function. Now moving on to the third one, we have the logarithmic function. So now these two, they are kind of like opposite functions. So if you want to find the inverse of exponential function, it will give you an logarithmic function as an inverse. So for for logarithmic function, in order to find the inverse of logarithmic function, it will give you an exponential function as the inverse. So now let's try to solve it. So you have y equals to negative log base 1 over 3 of x. So now you interchange x and y, so this will become x equals to negative log base 1 over 3 of y. So now you have to get rid of this negative sign, divide by negative both sides, so now it will give you negative x equals to log base third of y. So now you want to solve for y. So in order to solve for y, then let me rather say, if you want to isolate y from this log, you basically have to rewrite this as an exponential equation. So now it means y will be equals to, what is our base? Our base is 1 over 3. So now it will be our base to the power of everything that is on our left hand side, which is negative x. So now it will be 1 over 3 to the power of negative x. So now it means y equals to 1 over 3 to the power of negative x is the inverse function of our function y equals to negative log base 1 over 3x. And the last one, we have y equals to x squared. Y equals to x squared. So now y equals to x squared, we know that it is the parabolic function. So now y equals to x squared, it is this parabolic function. So now our parabolic function y equals to x squared, is it a one-to-one function? That's the first question. Well, this one, so that's why we have to be a little careful for parabolic function. We have to check if whether it's a one-to-one function. So now, applying our horizontal line test, you see that this function touches this line twice. So it means the ratio of y is to x is gonna be 1 is what? Is to 2. And remember, in order to find the inverse of a function, you have to swap the x and y values. Then it means if you have to find the inverse of this function, then the ratio of y is to x for the inverse. For the inverse will become what? Will become 2 is to 1, which is unacceptable for the function. Remember the definition of a function. We are saying that the ratio, the acceptable ratio for y is to x must be 1 is to 1. So now we have for this parabolic function, if we have to find the inverse of this parabolic function, we'll have something like this. So this will be the inverse of this parabolic function. So if we would have to apply our vertical line test, there's also this test called the vertical line test. That's when we test the ratio of y is to x. If whether the ratio of y is to x, is it acceptable, meaning is it 1 is to 1. So if we were to apply this vertical line test, it would fail, because this test, this vertical line, it would touch our inverse function twice, meaning for the x coordinate we have 2 corresponding y values, which is unacceptable. So now, in order to find the inverse of a parabolic function, we have to restrict the our x, or let me rather say our domain for our original function. So now, let me erase this. So now, let's firstly try to solve or find our inverse function. So we are going to say, let's swap x, let me rewrite this firstly, x squared. So now let's swap x and y. It will be x equals to y squared, right? So now solving for y, we'll have y equals to plus or minus square root of x. So now this will have a ratio of 2 is to 1. So in order for our inverse function to not have that ratio, we have to restrict our domain for our original function. So now remember that the domain for this function is the set of all real numbers, right? So now we have to restrict our domain. So now we are going to say, let x to be what? 0 or greater than or equals to 0. So now we have restricted our domain to be greater than or equals to 0 for our original function. Then therefore we can say the inverse function, it will be y equals to square root of x, whereby y is what? Y is greater than or equals to 0. So that's how that is how you can find the inverse of the parabolic function. So yeah.